Hi everyone! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about dynamics of rigid bodies. Ang discussions natin ngayon ay nakafocus sa kinematics of particles. At ako ay naghanda ng apat na problems para sa topic na ito. Ang tatlo doon ay makikita nyo ang solutions at ang isa ilalan ko para sa inyo kung nais ninyo siyang solvin para malaman kung sa pamamagitan itong discussions natin ay nasundan ninyo ang ating topic. Guys, puntahan natin itong ating topic. It's all about kinematics of particles. At magsimula tayo sa ilang definitions of concept or terms. Pag sinabi nating constrained motion, minsan kasi ma-encounter natin yung tinatawag na constraint motion. Lalo kapag tinutukoy na natin ay yung may kinalaman sa motions of a particle. Ang sabi dito, if the motion of a particle is confined to a specific path, then the motion is said to be in a constrained motion. Kapag daw ang motion ay confined lamang sa specified path, tinatawag natin siyang constrained. Na kung saan in a constrained motion, the direction of motion is not easily affected by external forces. Kumbaga, since ang kanyang motion is guided, so we cannot easily affect the motion or particularly the directions of that motion. To give you an example of this constrained motion, we have a bead that is sliding along a fixed wire. If you have a bead that is sliding along a fixed wire, then that motion is considered as a constraint because the motion of the bead shall be along the direction of that fixed wire. O kaya naman, if you have a rock that is tied to the end of a string and whirled in a circle, kaya meron kang bato, tinali mo sa isang string at pinaikot-ikot mo, ang tawag doon is constraint kasi yung motion ng stone is only confined to the circle whose radius is equal to the length of the string. O kaya naman you have the motion of a piston inside the cylinder of an engine. You will notice that the motion of the piston is just up and down. It is guided by the cylinder. So whatever force you apply, you cannot change the direction of that motion. It will only be moving in up and down direction. That is how we consider a constrained motion. While an unconstrained motion is that it is the motion of a particle that is not physically guided. So your motion niya is not physically guided. So when you have that kind of motion, so yung motion tinatawag nating unconstrained motion. So to give you an idea, the unconstrained motion, if you have a particle that is moving on this kind of motion, the direction of motion is easily affected by an external force. Halimbawa, the gravitational pull of the earth will change the direction of a motion if the motion is really falling. Ang halimbawa niyan ito, imagine din natin of the rock that is tied on a string. While the string is while the rock is rotating around the string, then the motion is considered as a constraint. But when the string breaks, then the motion becomes unconstrained because the stone or the rock will now travel in any direction. And once that is traveling in that direction, the motion of that rock will now be affected by an external forces. So halimbawa rin yung billiard balls, yung mga mahilig dyan sa billiard, when a ball is hit by a cue or another ball, so the ball can go in any direction, because the motion is unconfined. So you can easily change the direction of the motion because of the external force coming from the cue or coming from another ball. So ituloy natin, when we are talking of motion, it is very, very important that we shall be able to describe the position of and motion of a particle. And how do we normally describe the position of a particle? There are three ways in describing the position of a particle. One way of describing it is that it can be described using the rectangular coordinates, as what we have learned in our study of statics of rigid bodies. When you have a point in space, you can describe the position of the point by the respective rectangular coordinates, the distance of the point along the x, along the y, and along the z direction. If you have here a point P, and its point is a position is described by its distance along the x-axis in terms of the x, along the y-axis as shown by this one, and along the z-axis, then the coordinate of this point can be described, and the description is called a rectangular coordinate of the point. Sometimes we also specify the position of the point by the cylindrical coordinate. So ano ba itong cylindrical coordinate? It looks like you are forming a cylinder. So it is given in the form r, theta, and z. And I'll explain to you the purpose of r, what is this r, what is this theta, and what is this z. And I'll explain it by showing this illustration. Yung ordinate tutukoy dito is the distance of the position of the particle from a reference fixed axis, in this particular case, the z-axis. The distance of this point from that axis is measured in terms of r. While this theta is the angle that the position of the particle or the particle from another reference axis, or that ray coming from that ray that will connect the origin to the position will be making with respect to another reference axis, and that is called as the theta. While this z is the height of the position of the particle from a reference plane. And in this particular case, the plane is the x and y plane. So that the z is the distance from this xy plane called the z. So that this is referred to r, theta, and z. And we call this as the cylindrical coordinate. Sometimes we also use the spherical coordinate of the position given in terms of r and a pair of an angle. So how do we explain this spherical coordinate? When you say spherical coordinate, yung r is the distance, tumutukoy yan sa distance of the point from a reference fixed point. And theta and phi refers to the angle that this position will be making to a reference axis. And so if we're going to show it here, I have here an example of how this P is represented in terms of its spherical coordinate, na kung saan itong r na ito ay tumutukoy sa distance mula doon sa reference point, na kung saan yung reference point ay yung intersection ng three mutually perpendicular axes, the x, the y, and the z axis. And therefore, the distance is referred here as the r. Yung theta na ito naman, tinutukoy is the angle that this OR, the distance of this OR is making with respect to the z axis, And this phi is the angle that the same OR will be making with respect to the z-axis. So, ang ibig sabihin yun, dalawang reference axis na tinutukoy natin dito. So, you have the axis z and the axis y, while the r is the distance from the reference point, which is the intersection of the mutually perpendicular axis x, y, z. Okay? So, ituloy natin, So, when we are talking of motion, hindi natin maiwasan to describe or to describe the relation of that motion from reference point. And when we say absolute motion analysis, ang ibig sabihin nito, we are describing the coordinate of the position of a particle with respect to some reference axes that are fixed in position. Kapag ang pinagbabasihan nating reference position is fixed, at in-refer natin ang position ng ating particle from that fixed position, ang tinatawag natin, ang tawag doon is absolute motion analysis. Magbigay ako ng halimbawa. I have here an example. You would see in the figure a car and a gasoline station. If the gasoline station is fixed in its position and we wanted to describe the geometry of the motion of this car with respect to this gasoline station, which is fixed, then the analysis that we are actually doing is an absolute motion analysis, because we are referring the motion of this car from a point or from a reference positions that are fixed. Halimbawa, nag-move itong car in that direction. Okay, after some time, we wanted to determine how far it is from the gasoline station, how fast is this moving from the gasoline station, at what time it will be at a certain distance from a gasoline station. Then that actually is referred from a gasoline station which is fixed in position, and therefore the analysis that we are actually doing is an absolute motion analysis. However, if we are talking of a reference position that is also moving, then we are actually doing a relative motion analysis. Relative because the reference axis that we are using in describing the position of that particle is also moving. And here is the explanation. Sabi dito, whenever the motion of a particle or rigid body are described by using the coordinate measured from a moving reference axis, then the motion is described as a relative motion analysis. Para mabibigay natin ng isang magandang halimbawa, let us imagine here that we have here two vehicles, one car and a trailer. So if we wanted to describe the position of this car from a trailer, while the trailer is also moving, then the motion that we are actually doing, the analysis that we are actually doing is a relative motion analysis. Halimbawa sabihin natin, let us let them move. As the two moves and we wanted to determine how fast is this car moving against the track, or what is the distance of this car from the track after some period of time, or after how many time, after how many seconds will this car be at a certain distance from the track, and the track is moving. Therefore, the motion that we are actually, or the analysis that we are actually using is a relative motion analysis. Again, we say relative motion because the reference axis that we are using is moving. Okay? Now let us continue with our discussion, and from this part of the discussion you will understand a rectilinear motion, and we will be able to describe the geometry of motion when the motion is along a straight line. Let us try to understand ano ba ito tinatawag nating rectilinear motion. Pag sinabi nating rectilinear motion, kapag we are requiring only one coordinate axis along with time to describe the motion of a particle, then it is said to be in a linear motion. And when we say linear motion, we call this as a rectilinear motion. Kapag daw ang motion or ang description ng motion ng isang particle ay dinidescribe lamang natin using only one direction, only one coordinate axis. Halimbawa sabihin natin x-axis lamang, y-axis lamang, o kaya vertical axis lamang, or along the z-axis lamang, then we are only referring to one direction. And when we are talking of one direction, that is moving along a straight line, then the motion is said to be a rectilinear motion. Okay? So, in a rectilinear motion, kinakailangan maunawaan natin dito, ano ba yung mga formula that may be involved in dealing with the geometry of motion, particularly in the kinematics of particles. Now, let us here consider an example, an illustration of a particle that is moving along a straight line. Sabi dito, if you are to consider a body or a particle P that is moving along a straight line, here is the body. In this particular case, we call it a car. But we call it a particle because the dimension of this car may be small enough comparing to the dimension of the line or the path that it will be traversing. So it will be called as particle. Then the position of the particle P at any instant of time. Diba? Halimbawa sabihin natin, at any time t, its position is at P. And it can be measured by its distance s from a fixed point on the line. So if we will be using this O as our reference point, then the position of this particle at any instant time t will be at P. And the coordinate of that P from this reference point is given here as x. Okay? Now at any time, at a time t plus delta t, ang ibig sabihin ng t plus delta t, there was already an elapsed time. Ba? Nagkaroon na ng pagbabago sa oras. Halimbawa, kanina is 30 minutes. 30 minutes ago, dadagdagan ng 3 seconds. Ibig sabihin, the elapsed time is 3 seconds. Okay? At time t plus dt, okay, the particle has moved to another position and we shall be calling it as P prime. So, nag-move na daw siya dito sa P prime. Diba? Now, ang coordinate ngayon itong P prime na yon ay magiging S plus delta S because the position now has moved to a position by moving it a delta S, di ba? Now, the change in the position coordinate during the interval dt shall be called as the displacement. Itong delta S nito, tinatawag nating displacement. It is called as the change in the position during the elapsed time delta t. And the displacement would be either positive or negative depending on the position of the delta p. Sometimes it is at the back of the original position, therefore the displacement shall be called as negative. Sometimes it is in front, and therefore the displacement shall be positive. Hence, the displacement could be negative or positive depending on the final position of the p prime. Now, if we're going to consider here, for us to be able to really understand how to describe the motion, particularly when the motion is along a straight line or in a rectilinear motion, it is very, very important that we should understand here some concepts about velocity and acceleration. And in this particular case, kinakailangan nating maunawaan ano ba ito tinatawag nating average and instantaneous velocity. So, puntahan muna natin. Ano bang ibig sabihin ng average velocity? Pag sinabi natin average velocity, sabi dito, the average velocity of the particle during the interval o delta t is the displacement divided by the time interval. If the distance is 10 kilometers and the total time is 10 minutes, therefore, it has traveled 1 kilometer for every minute. That's what we mean by average velocity. Okay? However, kinakailangan natin maunawaan dito, ano ba naman yung tinatawag natin instantaneous velocity, Pag sinabi natin instantaneous velocity, ganito yun. As the time interval delta t in the above formula, dito sa formula ito, becomes smaller and smaller and approaches zero in the limit. Ito daw delta t ay masyadong paliit na paliit hanggang sa yung limit niya ay naging zero. Then, the average velocity, itong average velocity nito, will approach what we call the instantaneous velocity. Kaya kung susulat natin siya, ganito ang representation ng instantaneous velocity. Sabihin, the instantaneous velocity, which is represented here by V, is the limit of delta S over delta T as delta T approaches zero. As the time difference or the time interval becomes very, very small and it approaches zero in the limit, then the average velocity that we have here will become the instantaneous velocity. And if we have this kind of representation, then this limit of the delta S with respect to the delta t as delta t approaches zero is actually our definition of the derivative of S with respect to time t. They are also called as the time rate of change of the position coordinate. The time rate of change or ds over dt. Now, ganun din ang application sa tinatawag nating average and instantaneous acceleration. Pag sinabi nating average acceleration, tumutukoy yan saan? Sa ratio of the change in the velocity divided by the time interval. Kaya kapag isinulat natin siya, yung average acceleration is equal to delta v over delta t. Ngayon, pag sinabi natin instantaneous velocity, ganun din. If delta t becomes smaller and it approaches zero in the limit, then this average velocity will now be called as, or will approach the instantaneous velocity. As such, instantaneous velocity will be equal to the limit of delta v over delta t as delta t approaches zero. And if this will be written in another form, this is written as acceleration is the derivative of v with respect to time t. So yun yung ating understanding or application of how do we describe average acceleration, average velocity, instantaneous acceleration, and instantaneous velocity. Ituloy natin ang ating discussion. Now, in this study, we shall also be learning about some geometry of motion. When the motion is traveling along a straight line and whose acceleration is constant. And we call this as rectilinear motion with constant acceleration. Ang ibig sabihin acceleration, hindi nababago. Hala? Okay. So, balikan natin yung formula na ipinakita ko kanina, yung acceleration. Diba? Acceleration daw is the rate of change of velocity with respect to time t. In symbol, it is written as dv over dt. Diba? Ngayon, kung ating ko cross-multiply ito, because this is actually a differential equation, if we will cross-multiply, and then we write it as a times dt shall be equal to dv. So we have the product of a constant acceleration a multiplied by the derivative of time t, is equal to the derivative of v. If a is constant, then we can integrate both sides of the equation with a taken out of the integral sign, so that if the left hand side of the equation is integrated with the limits of integration from the initial time of observation t sub 1 to the final time of observation, which shall be called as t sub 2, while the right hand limit, derivative of v is integrated from the limit of v sub 1, which is the initial velocity at the first observation, to v sub 2, the final velocity at the final observation. Then our equations becomes a multiplied by t evaluated from t1 to t2, and this will be equal to v, which is evaluated from v1 to v2. And if we're going to evaluate the limits of integration, then the equation becomes a times the quantity t2 minus t1 shall be equal to v sub 2 minus v sub 1. And if this equation shall be rearranged, then this equation will become v sub 2 minus v sub 1 is equal to a times t sub 2 minus t sub 1. Or simply, this becomes equal to v sub 2 shall be equal to v sub 1 plus a times the quantity t sub 2 minus t sub 1. If we are going to substitute t sub 2 minus t sub 1 equal to t, which is called as the elapsed time, then our equation 3a will become equal to v sub 2 shall be equal to v sub 1 plus at. And from here, I think you're already familiar with this equation, because this equation is already, you already have encountered this equation in your physics. Ano? So pinakita ko lang dito yung paano siya na-derive, yung relationship between the final velocity, the initial velocity, acceleration, and that of the time. Okay? Ito din natin. If we're going to consider equation 1 and equation 2, ano nga yung equation 1 natin? That's really the description of the acceleration and the velocity. Ano? Yung velocity is equal to ds over dt. Yun yung ating equation 1 na pinakita kanina. Samantala yung ating equation 2, and from here, by the way, from this equation, you can find that d sub t or dt shall be equal to ds over the velocity, the ratio of ds over the velocity. While equation 2, which is equal to acceleration equal to dv over dt, and from here, our dt will be equal to dv over a. And because they are both equal to dt, ibig sabihin yan, we can equate equation 1 and 2, di ba? So that if we're going to equate 1 and 2, therefore our ds over v will be equal to dv over a. And again, we are going to examine this equation. It's actually a differential equation which can be solved by variable separable. So if we will be cross multiplying both sides of the equation, therefore our equation becomes a multiplied by ds shall be equal to v multiplied by dv. And again, how are we going to simplify this? If we will integrate both sides of the equation with the left hand side of the equation, having a limits from s sub 1 to s sub 2, whereas the right hand side equation shall be evaluated with the limits from v sub 1 to v sub 2. Therefore, our equations becomes equal to a times s evaluated from s sub 1 to s sub 2 shall be equal to v square over 2 evaluated from v sub 2 to v sub 1 to v sub 2. And if we are going to evaluate the limits and then rearranging the terms, the equations becomes equal to b sub 2 square minus b sub 1 square shall be equal to a 2a times s sub 2 minus s sub 1. Okay, makita natin that you have here S sub 2 minus S sub 1. Ano? If this S sub 2 minus S sub 1 shall be replaced by the change in the position, which shall be called as S. Therefore, the equation becomes B sub 2 square minus B sub 1 square shall be equal to 2AS, where S is the change in the position. Take note here that S sub 2 is the distance traveled, okay, during the second observation, and S sub 1 is the distance traveled during the first observation. And between the two, the difference between the two is the change in the position. So that you will have here B sub 2 square minus B sub 1 square equal to AS, the formula that you have in your physics. Ano? Okay, medyo baka bigla lang kayo na-recall na ganito, bakit nagkaroon ng S sub 1 dito? Samantalang nga naunawaan ko, it's just equal to 2A times S. Okay? So ituloy na natin. Okay, so if we're going to solve for the distance traveled, okay, how are we going to solve for the distance traveled? I-recall ulit natin yung formula. Ano? Yung formula ng equation 1 natin is V equal to ds over dt. Kaya lang kanina, okay, na-discuss na natin, and from here, we shall be able to have ds equal to V multiplied by dt. At kanina, okay, we already have solved that V is equal to V times 80. And if this value shall be substituted here in this formula, therefore we shall have ds equal to V1 plus 80 multiplied by dt. And again, if we're going to look at this equation, this is actually a differential equation, which can be simplified by integrating both sides of the equation. That if the left-hand side of the equation shall be integrated, okay, with the limits, okay, on the left from S sub 1 to S sub 2, while the limits on the right shall be, you're talking of these t's, therefore this will be t sub 1 to t sub 2. Therefore, if we are going to integrate, then the left-hand side becomes S sub 2 minus F sub 1, while the right-hand side shall be equal to B sub 1 times T sub 2 minus T sub 1. In here, I already have evaluated the limits, okay, plus 1/2 of A times T sub 2 minus T sub 1. And again, if we will let T, which is the difference between T sub 2 minus T sub 1 as the elapsed time, and we replace it here in the formula T sub 2 minus T sub 1, therefore our equation becomes S sub 2 minus S sub 1 shall be equal to B sub 1 square plus 1/2 of A T square. Again, if we will be, okay, substituting S sub 2 minus S sub 1 as the displacement, that equation becomes S as a displacement, representing the difference between S sub 2 minus S sub 1 shall be equal to B sub 1 T plus 1/2 A T square. In cases where the initial position or the distance traveled is 0 before the observation is taken, then the equation becomes S sub 2 equal to B sub 1 T plus 1/2 A T squared, or this may be simply called as the difference between the final distance or the distance traveled during the second observation minus the distance traveled during the first observation. Right? And as I have explained a while ago, I have prepared here, okay, 4 problems, but in this particular discussion I will be presenting only the first 3, and I will leave the 4th one to you. It's up to you. We wanted to test yourselves after seeing the solution to the 3, whether you are able to follow or not our presentation. And I have here the first problem. The first problem is about a ball that is thrown vertically upward at 150 feet per second, and after 3 seconds, another ball is thrown vertically. What initial velocity must the second ball have to pass the first ball at 100 feet from the ground? So yun yung ating first. Mamaya babalikan natin ito. Pakita ko lang yung second. There is a train moving with constant velocity, constant acceleration that travels 24 feet during the 10th second, and 18 feet during the 12th second of its motion. Find the initial velocity. The third, you have the balloon that rises from the ground with a constant acceleration of 3 feet per second squared. Then 5 seconds later, a stone is thrown vertically upward from the launching side. What must be the minimum initial velocity of the stone to just touch the balloon? Note that the balloon and the stone have the same velocity at contact. And the fourth one is about an auto that's moving at 24 feet per second and accelerating at 5 feet per second square. That is to overtake another O to B, which is 400 feet ahead. And then if O to B is moving at 75 feet per second and decelerating at 3 feet per second square, how soon will A pass B? So meron tayo yung apat na problem. Subukan nating ipakita dito yung solutions sa tatlo para iwan ko naman sa inyo yung pangapat. And you may test yourselves if you're able to follow, okay, after seeing the solution to the first three problems. And here is our first problem. Balikan natin yun, There is a ball that is thrown vertically upward at 150 feet per second. After 3 seconds, the ball is thrown vertically. What initial velocity must the second ball have to pass the first ball at 100 feet from the ground? Medyo i-analyze natin mabuti yung problem. Sabi dito, meron daw bola na the bola is given an upward velocity of 100 feet per second. So, pagkatapos ng 3 segundo, another ball is thrown vertically. So, the question is, ano yung dapat yung velocity ng second ball para daw malagpasan nitong second ball yung first at 100 feet from the ground? Ito tanong In what direction kaya that the second ball will be passing the first ball? Ibig kaya bang sabihin nyo na ma-overtaken niya yung first ball? O yung second ball will will pass the first ball while the first ball is already falling down. Diba? So, kailangan magkaroon tayo ng analysis ng motion of the first ball. Una, dahil given yung kanyang velocity at 100 feet per second, so tingnan natin ang kanyang position after 3 seconds. Wala pa muna tayong solution na ina-analyze pa muna natin yung problem para maipakita natin later on kay yung correct approach in dealing with this one. So if we're going to apply the formula for the displacement, that is S sub 3, which is equal to B sub A 80 plus 1 half 80 squared. Kasi dito, given na lahat, initial velocity at saka yung time na 3 seconds. So that if we are going to substitute the formula, okay, makukuha natin, kung saan dito yung acceleration daw, will be the acceleration due to gravity, and in this case, because the ball is thrown vertically upward, so ang magiging G natin is negative because the direction of the velocity is opposite the direction of the acceleration due to gravity, and that is negative 32.2. So if we're going to substitute that in the formula, okay, the distance that we are getting will be 120 multiplied by 3 plus 1 half times negative 32.2 times 3 squared. And that S sub 3 will be 215.1 feet. Itong S sub 3 tumutok sa the distance traveled after 3 seconds. Okay, balikan muna natin. Meron na tayong 215.1 feet. Ang sabi dito, kinakailangan malagpasan ng ball B, si ball A at 100 feet per second. 100 feet from the ground. So, ibig sabihin, walang tsansa o hindi posible na malagpasan ni ball B itong ball A at 100 feet from the ground kasi sa loob ng 3 segundo bago pa i-release itong second ball, itong ating first ball ay nandun na sa height na 215.1 feet. So, ibig sabihin, ang chance is that pababa na itong first ball natin at makakasalubong siya ng second ball at 100 feet from the ground. Ganun ang senaryo, itong tanong, pabaga, kailan siya magkakasalubong? Okay? So, since the distance traveled after 3 seconds is greater than 100, then the ball will not be able to overtake the first ball. Ang ibig sabihin nun, magpakasalubong na lamang sila sa panahong pabagsak ng muli itong ating ball A. Kaya ipakita natin yung senaryo, Solve natin yung maximum height kasi ang tanong, kailan siya magpababa na ba siya o magpapang-abot pa siya? Okay? Ang maximum height na makukuha natin using the formula, from the second formula that we have is that B sub A2 square shall be equal to B sub A1 squared plus 2AS na kung saan B sub A2 is the final velocity of the ball. Ibig sabihin, ito yung velocity ng ball dun sa pinakamataas niyang position. And this is already equal to 0 because the ball stops at the highest point before going back downward. Diba? Kaya, if we are going to substitute that B sub A2 equal to 0 here, then we shall be getting the maximum height. The S max, the maximum height that the ball could travel given the initial velocity of 120 feet per second. And that you will be getting an S of 223.6025. Ang ibig sabihin to, balikan lang natin na, at 3 seconds, meron na siyang 215. At pagkatapos, ang pinakamataas niya matatravel according to our formula, to our equation, is 223.605. Ibig sabihin, malapit na kay marating nitong ball 1 yung pinakamataas bago ma-release yung second ball. Di ba? Siguro mas maganda kung ipapakita natin siya yung animation ng dalawang bola, dalawang bola, para maunawaan natin yung konsepto, and then from there, magkaroon tayo ng solution. Okay? Pakita natin, halimbawa ito yung ground. And then, from the ground, here is the first ball that is released at a velocity of 120. Sabihin, na-reach na niya yung 100 bago pa lumabas yung pangalawang bola. Ibig sabihin, madaanan na niya yung height na 100. When, after 3 seconds, nasa na siya? After 3 seconds, yung bola ay narito na kinumpute natin na 215.1 feet. Diba? Narito na siya. Saka pa lamang i-release yung second ball. But this 215 is almost at the highest because the highest is 223. Kaya kung aakit na siya na konti, may natatabil na rin itong ating bola. Pero na-reach na ng first ball yung maximum of 223.6. And once this is reached, ano ngayon mangyayari? Babagsak na itong unang bola, subalit itong ating second ball ay patuloy sa taas until they meet at the height of 100. Saka pa lang ulit sila magpapanagpo doon sa scenario na yon. Yun ang kesa, ulitin uli, no? So ito yung mangyayari, pakita natin yung mangyayari. The ball is released at the height of 100, dinaanan na niya, then at 3 seconds, saka pa lamang i-release yung first ball, ni-release yung first ball, na-reach yung maximum height, and then after reaching the maximum height, nagpanagpo ngayon siya sa height na 100. So yun yung ating magiging konteksto ng ating solution. So what will be our guide in solving the problem? Sabi dito, ang guide natin dito, una, kinakailangan natin ma-define yung total time, the time in seconds. Will the first ball pass the 100 feet mark? Nakita nyo kanina, mayroong dinaanan niya yung 100 feet mark. Sabihin, gaano katagal niya dinaanan yun? At 2 beses niya dadaanan yun. Yung una, pataas siya, then pangalawa, bumagsak na siya. Sa makatuwid, kinakailangan natin masolve. Ano yung time na dinaanan niya, yung 100 mark na yun? And this can be taken using the formula that we have. Note that there are 2 cases where the ball passes the 100 foot mark. The first is when it is going upward, and the second one is when it is already falling down. It is falling down, Okay? So, second one, solve natin yung time that the second ball will pass the 100 foot mark. Note that the second ball was released 3 seconds later. Mas huling in-release yung second ball. Sa makatuwid, the time traveled by the second ball, will be 3 seconds less than the time traveled by the first ball. Kaya kung masolve natin sa number 1, yung total time that the first ball passed the 100 foot mark, bawasan lamang natin siya ng 3 seconds, so makatuwid yung time na kung sa dadaan naman yung second ball doon sa 100 foot mark. And that gives us the answer. Diba? Now, so that, pag nasolve na natin yung time nito, solve natin yung initial velocity required for the second ball using the completed time into using ns equals 100 feet. And from there, masosolve natin yung problem. Okay? So, pakita natin solution. Pakita natin, So, this formula will solve S sub 3. Okay? From here, we shall be able to solve the time t, time t, where the first ball will pass the 100 foot mark. Okay, and I will substitute here 100 shall be equal to 120t plus 1/2 of negative 32.2 square times t square. Na kung sa dito is the time that it will pass the 100 foot mark. And therefore, when that would be simplified, I will have an equation that is 16.1 t square minus 120t plus 100 equal to 0. And actually, this is quadratic equation, which can be solved by quadratic formula. Or if you have a more sophisticated calculator, you can simply enter this equation and you can solve for t using shift solve. But if you don't have that kind of calculator, you can solve it using the quadratic formula. And from here, you will have two values of t. The first value of t that you will be getting is 0.956 second. Okay? And ito yung time na dadaanan ng bola. Okay? The first time that the ball will pass the 100 foot mark. Siya yung time na pataas pa lamang siya. While the second t, which is 6.497, na masusolve niyo sa inyong calculator, okay, will be the time that the ball, okay, will have, okay, and that is the time when it's already going down. Pababa na siya. Diba? Ngayon, kung mula dito sa t sub 2 nito, which is 6.497, kung babawasan natin ito ng 3 seconds, because sabi diyan, okay, therefore, the second ball will travel 3.497 to reach the 100 foot mark. Kasi yung second ball daw will be 3 seconds less than the total time that the first ball has traveled while reaching the 100 foot mark. And therefore, the t that the second ball will have will be 3.497. And if this will be substituted in the formula for S sub b, okay, which is equal to v sub b squared plus 1/2 a t square, where S sub b is 100 kasi 100 lamang naman yung tatakbuhin niya. And v sub b is the initial velocity. Yung time t is the time that we have solved for, okay, the time that it is traveling. So that from here we can substitute the value and that you will have the velocity equal to 84.9 feet per second. So para maunawaan natin mabuti, let us again go back to the animation that we have. Pakita ulit natin siya at ito yung mangyayari. So ito yung bola, okay, nirelease siya after, okay, 0.956 seconds. Ito yung 0.956 seconds na nakuha natin. Na-reach na niya yung, okay, 100 foot mark. Diba? Then, okay, nirelease pa siya, tuloy-tuloy ang release niya. After 3 seconds, okay, na-reach na niya yung height na 215. Pero bago yung pa lamang sisimulang kay ma-release yung second ball. Kaya nang in-release yung second ball, kay narating niya ngayon yung maximum height, ito na yung natatravel ng second ball given at a velocity of 84.9, di ba? Napababa na ito, then they will be meeting at that position at 100 and the time for the second ball is 3.49 while the first ball is 6.49 and that it has an velocity of 84.95 feet per second. And so that is our answer for the first problem. First problem. Now let's go to the second problem. The second problem is something about, okay, the motion of a train along a straight path. Sabi dito, a train moving with a constant acceleration travels 24 feet during the 10-second motion and 18 feet during the 12-second motion. Find its initial velocity. Okay, sa mga familiar sa libro, itong problem na ito ay kinuha ko sa libro ni Singer, yung Statics of Rigid Body ni Engineer Singer. Somewhere on that particular part, I took this problem. Baka ma-encounter ninyo ito, at least you will be able to solve this problem. So, let's have here our analysis. Sabi dito, note dito, meron dito tinutukoy na 10 second of each motion and it has traveled 24 feet. Yung sinasabi dito 10 second, okay, ay tumutukoy sa isang segundo lang yun, isang segundo na yung time ay matatagpuan between t equals 9 and t equals 10 seconds. Similarly, ganun din, okay, kung titignan natin dito, halimbawa ito yung straight line, at ito yung tinutukoy nating time traveled by the train after 9 seconds. Ito na yung haba. Then after 10 seconds, yung train narito na halimbawa. Yun, narito na pala halimbawa. Ito yung after 10 seconds, narito na yung train. Ang ibig sabihin nun, itong distance na ito from t equals 9 to t equals 10, ito yung distance traveled. okay, which is 24 given in the problem, okay, during the 10 second of the time. Diba? Similarly, yung sinasabi naman ditong 12 second of the time refers to, again, a 1 second period. Isang segundo din lang yon between t equals 11 and t equals 12. Kung titignan natin, nasaan na ba yung train when t equals 11? Maaaring yung train ay narito na yung when t equals 11. Ano? At yung train ay narito somewhere here when t equals 12. Yung sabihin, the distance traveled when t equals 11 and t equals 12, ito yung sinasabi dito na 18 feet. Ito yung 18 feet na tinutukoy. Ano? And this is the distance traveled during the 12 second of the time of each motion. Diba? Again, itong 18 feet tumutukoy sa distance traveled sa loob ng isang segundo doon sa panglabing dalawang segundo. Samantalang itong 24 seconds na pinapakita dito, 24 feet na pinapakita dito, isang segundo sa loob ng in between t equals 9 and t equals 10 seconds. Okay? Ang pinapahanap sa atin the initial velocity of the train. Now, puntahan natin. If you're going to solve for the distance traveled for each of the time, t equals 9, t equals 10, t equals 11, and t equals 12, using the distance formula. Ano ba yung distance formula natin? Ito yung distance formula. S equals b sub 1t plus 1/2 times a t squared. Diba? Okay, pakita natin. We're going to substitute. When t equals 9, ano yung ating distance? I will be using S sub 9 because I am referring here subscript as the time. Therefore, ibig sabihin, ito yung distance traveled when t equals 9. And this is equal to b sub 9 because the time is 9 plus 1/2. The acceleration is not known, but multiplied by the t squared. And if this will be simplified, this becomes, ito yung lumalabas, ano? S sub 9, and this will be equal to, 9 v sub 1 plus 40.5a. At ito yung tinatawag nating S sub 9. Similarly, when t equals 10, pag substitute natin yan, S sub 10 becomes b sub 1 times 10 plus 1/2 times a times 10 squared. Ito naman yung distance na tinutukoy natin, when s equals 10. And if this will be simplified, s sub 10 becomes 10 v sub 1 plus 50a because 100 squared divided by 2 is equal to 50. Now, ano sabi dito? Ang sabi dito, the distance traveled between, during that 10 seconds is 24. At kung titignan natin yun yung s sub 10 minus S sub 9 kasi S sub 10 mula dito, yung S sub 9 mula dyan sa liquid, S sub 10 minus F sub 9 is equal to 24, di ba? Sabi dyan, kung makita na S sub 10 minus S sub 9 is equal to 24. And if the two equations shall be substituted, ito tsaka ito isasubstitute dito, therefore, I will have here, B sub 10 minus 58, ito yung ating S sub 10, minus, B sub 1 times 9 plus 40.5a, ito naman yung ating b sub S sub 9 shall be equal to 24. And if this will be simplified, 10 minus 9 equals b. 50 minus 40.5 is 9.5. A equal to 24. And I will be calling it as our equation 1. Diba? Ngayon, puntahan naman natin itong distance travel during the 11 and 12 second. Ano? So I will have here, when t equals 11, ito tayo, no? Anong ating S11 equals V times 11 plus 1/2 times A times 11 square. And this distance is this distance. Ito yung distance nito. Mula dito sa reference hanggang sa t equals 11. Ito yon. And if this will be simplified, that becomes 11 b sub 1 square plus 60 because 11 square is 121 divided by 2 is 60.5a. So I will have this as our S of 11. And when t equals 12, ito na yun, no? Ano nga yung ating distance? Our distance is this distance, 12. And the formula will be equal to, S sub 12 becomes b times 12 square plus 1/2 of a times 12 square. And when this is simplified, I will have here, 12 v sub 1 plus 72a. And again, if you're going to look at the figure here, sabi dito, yung S sub 12 minus S sub 11 is equal to 18 as seen in the figure. Therefore, I will have here, S sub 12 minus S sub 11, this 11 shall be equal to 18. And therefore, I will have here B sub 1 times 12 plus 7 to a. Ito yun. diba? Minus this part which is equal to b sub 11 times 60.5 shall be equal to 18. And if this will be simplified, 12 minus 11 will be equal to b sub a. Then 72 minus 60.5 will be 11.5a shall be equal to 18. And let us call this as our equation 2. Now we have here two equations. Equation 1 and equation 2 involving b sub 1 and a, which can be solved easily by eliminating b sub 1 o kaya naman yung a, which can be easily eliminated if we shall be substituting, also subtracting equation 2 from equation 1. If this equation 2 shall be subtracted from equation 1, our equation becomes, tingnan natin, b minus b shall be 0, 9.5a minus 11.5a is 2a, then 24 minus 18 is 6, and from here, a equals negative 3 feet per second square. Ang ibig sabihin nun, yung train pala ay bumabagal ng 3 feet bawat segundo. Ano bawat segundo? And therefore, if this a shall be substituted in either equation 1 or 2 that we have here, so we can solve for the initial velocity. It's either substituted in 1 or 2. Okay, if this will be substituted here, so bakit na natin substitute dito, no? So I will have b sub 1 shall be equal to plus 11.5 times a shall be equal to 18. If a substituted with negative 3, therefore b sub 1 is 52.5 feet per second. And that is how fast the train travels initially. Okay, that during that given period of time, it has traveled 24 during the 10 and 18 during the 12 period of each motion. And I hope that you're able to follow that second solution. And this is the third problem is something about very also interesting problem which I would like to share to you. And it's about a balloon. Yeah. Sabi dito, a balloon which is initially at rest rises from the ground with a constant acceleration of 3 feet per second square. 5 seconds later, a stone is thrown vertically up from the launching site. What must be the minimum initial velocity of the stone to just touch the balloon? Note that the balloon and the stone have the same velocity at contact. So, maganda na basahin natin mabuti yung problem. And before we solve the problem, okay, malaking bagay if we shall be making an analysis of the problem. So let us try to analyze the situation. So pakita natin yung balloon and then this. Here is the balloon and the balloon is released with an acceleration. After 5 seconds, okay, another ball is released until the ball touches. Okay, ulitin natin para makita. 5 seconds later, ito na ngayon yung position niya, and that's the time that the ball is released and the ball touches the ground, the balloon. Okay, so let us have an analysis from the scenario. Una, tingnan natin mabuti. How are you going to explain the distance that the balloon and the ball has traveled? If the ball is able to touch the balloon, ang ibig sabihin nun, okay, the ball and the balloon have traveled the same distance. So that's one analysis that we can have. The stone and the balloon have the same distance traveled at the point of contact. Otherwise, they would not meet. They would not be in contact. Although the time difference at the time of travel may be different, but the distance that they have traveled, at the point of contact are the same. Second, now let us try to consider, which of the two particles have traveled longer. You'll notice that the balloon travels, longer than the stone because the stone is released only after 5 minutes of initial travel of the balloon. Hence, the balloon's travel is longer. And how long is the time of the balloon than the time of the stone? So makita natin yan, the time of travel of the balloon is 5 seconds more than the time of travel of the stone before they are in contact. Because the stone is released 5 seconds later. Hence, yung balloon will be traveling more than the stone, and it is 5 seconds more than the time of the stone. So that from there, the time of the balloon shall be equal to t plus 5. Diba? What else? It is given in the situation, in the problem that okay, the balloon and the stone have the same velocity at contact, and therefore the velocity of the stone and the balloon at the time that they are in contact, okay, are the same. Hence, okay, yung kanyang final velocity of the stone shall be equal to the final velocity of the balloon. So that if we're going to solve for the distance traveled by the, doon muna tayo sa stone, ano, sa stone muna tayo. Okay, ito yan, ano. How do we compute for this distance traveled by the stone? Using the simple distance formula, S equals B sub 1 T plus 1/2 A T squared. So, tawagin natin dito yung T sub S at the time of the stone. And B sub 1S is the initial velocity of, okay, the stone na siya natin hinahanap in the problem. Di ba? And S is not known also, di ba? So, we can simply, we can substitute here, no? Na kung saan dito, yung ating B sub 1S is the initial velocity na kung saan siya na nga yung hinahanap sa problem. Samantalang yung A dito is the acceleration of the stone, and in this case, it is equal to negative g because the velocity is opposite the direction of the acceleration of the gravity. And so if we're going to substitute the formula, okay, S is equal to B sub 1 times T sub 1 plus 1/2, T sub S pala ito, plus 1/2 times negative 32.2 times T sub S squared. Ito yung ating magiging, okay, distance for the stone. Whereas for the balloon, the distance traveled by the balloon shall be, okay, taken using the same formula that you have V sub 1B times T sub B plus 1/2 of A times T sub B squared. Na kung saan dito, yung B sub 1B is the initial velocity. And in this case, it is 0 because the term of initially at rest. Ba? Samantalang yung ating T of the balloon is, okay, T of this stone plus 5 seconds. Ano mas mahaba yung T of the balloon? That if this will be substituted in the equation, S sub B becomes 0 plus 1/2 times 3 times Ts plus 5, 1 T squared, and then you have here S sub B equals 1.5 times Ts squared plus 10 Ts plus 25. Or simplified case, this will be our second equation. Now, if we're going to substitute, okay, in the relationship that this distance traveled by the stone is equal to the distance traveled by the balloon, therefore our equation becomes, okay, V sub 1S times T sub S plus 1/2 of negative 32.2 T sub S squared, which is our the distance traveled by the stone, diba? Shall be equal to 1.5 of the quantity Ts squared plus 10 Ts plus 25. And ito naman yung ating, okay, distance traveled by the balloon. Now, from here, we can have the relationship that B sub 1 times Ts minus 16.1 shall be equal to 1.5 Ts squared plus 15 Ts plus 37.5. And if we're going to solve for the velocity of the particle at their contact, then for the stone, we know that the velocity using the relationship between the velocities, that is V sub 2, the final velocity shall be equal to the initial velocity plus AT. Then we substitute that B sub 1 S minus 32.2 times T sub S. Okay, and therefore our final velocity will be B sub 1S minus 32.2S. Similarly, for the balloon, we can have that formula that the final velocity of the balloon shall be the initial velocity plus the product of A and the time. That A is given at 3, so when you substitute, that is 3 times T plus 5, Ts plus 5. Now, if we're going to substitute that they have the same velocity, this velocity is equal to this one. Now, equating the two, we shall have B sub 1 S minus 32.2 T sub S, representing the velocity of the stone during the time of contact, shall be equal to the velocity of the balloon, which is equal to 3 times the quantity T sub S plus 5. And from here, we can solve for B sub S, okay, that B sub S shall be equal to 35.2 T sub S plus 15. Now, if this V sub 1S is substituted in equation 3, okay, tawagin natin siya equation 4, at substitute natin siya sa equation 3. Therefore, our equation will come equal to B sub 1 S times T sub S plus negative 16.1. Okay, ito yun, ano? shall be equal to 15.1 t sub s square plus 15 t sub s plus 37.5. Actually, kinopya ko lamang mula yan sa equation dash 3. If b sub 1s, which is equal to 35.2 t sub s plus 15 is substituted dito sa bali nito, then that becomes 35.2 t sub s plus 15 multiplied by t sub s plus 16 or negative 16.1 t sub s square shall be equal to that of the left hand side of the equation. Kapag isinimplify natin to, combine similar terms, lalabas diyan is that I have 17.6 t sub s squared shall be equal plus 15t minus 15t shall be equal to 37.5, na kung saan itong dalawang 15t will cancel and that we can solve for t which is equal to 1.46 second. Now finally, if this t, which is equal to 1.46, is substituted in equation 4, and thus we can solve for the initial velocity of the stone, which is 35.2 times t sub s plus 15, when t sub s substituted at 1.46, therefore our value for the initial velocity will be at 66.4 feet per second. I hope guys that you are able to follow the discussions that I have presented to you, and with that discussion you will have the guts of trying to solve the last problem that I have given. So I hope that you will continue following us during in our discussions by subscribing to this channel, and again sharing it to your friends so that your friends will also be notified of these uploads. Once again, thank you very much for watching.